Hello there, this is Ed, the CNC Dude from Suncoast Technical College, and we're going to cover 3-axis machining with Fusion, and we're going to take a part from the Fusion course. This one's called a 3D Pocket Sample, which is in your upload file. So if you follow the script here, this is all in the roughing cycle, but we're actually going to use this as a complete part. So we're going to upload this file. It's not a design file. This is really just the CNC machining end of it. And we're going to turn on the Fusion here. And this is the 3D Pocket sample right here. This is the one you're going to upload. One you have in the class in which you upload a vise and you got to create this stock. This is stock boundary right here. So this is identified as a separate part. You got part and stock. So this is opacity control. You can make it thick or thin or transparent. I should say translucent, I guess. Yeah. But this would be a good symbol, and I've actually used this to make my little bit of a drawing for setup purposes. So I did a drawing file, and this is the finished dimensions of the part, but I also described the stock size here, 4" by 4 by 1" thick, and I wrote it right here. And we're going to use the center of the part for G54X0Y0 and the top of the material. And this is a description of how we're setting it up in our machine with the 200,000 step jaws, which are like built-in parallels. So, and this is the orange vise that you would import in here. And I'm going to go right to our project, completed project, 3D Pocket Sample, right here. And I'm going to go break it down, operation 1, operation 2. Let me wait till it comes up. All right, now let me shut off some of this stuff. I actually imported 2 vices so I could simulate both operations. This is operation 1 with vise and parallels and material right there. So if I turn on, shut off the vise, and I have body and stock right here. Stock, and I'm going to shut off some of these other operations here for display purposes. Okay, I'm going to zoom up on this. And I actually drew a sketch in here that I also want to shut off so you're not confused by that. That would be under sketches right there. Okay, so there's our model. I'll shut the stock off. So first thing we're going to do is do a setup. So I'm going to just backtrack this thing, and let me pause for a second. Okay, back to my, I just wanted to regenerate some stuff. So this is operation 1, and I'm going to actually back teach this. So we're using, this one I'm going to use stock box point. This is probably the simplest way to do a setup. And we're going to use the center of the material and the center of the top of the material. So this one, because we already identified the stock, I've actually did stock from model, because we're actually describing the material perfectly. Now the other way of doing it would be like fixed size box. You could use that. And the third tab, we're going to call this Program 3001 and name your project, and we're going to make this WCS1. We're going to start to do more complete parts, which will be combined operations. So you need to have WCS1 on. You can't use 0. You'll get an error when you go to post this. So we can do that, or you can actually make default so this comes up all the time. Okay. Hit OK, and that's going to take care of your setup. Now we're going to go to Facing Tool, and actually a little tips and tricks here. The manual NC area is right here, And there are actually little things you can put in your code, like a comment, a program stop, which would be an M00. Another one I like is start chip transport. That would turn on the chip conveyor if you didn't have it built into your code. What else do we have here? Force tool change. I like using that one if I'm calling up the same tool twice, but I want to have the ability to stop in between. And some of these you might have to experiment with, but I actually have this on the top as a comment, and I use it for setup information. So if I go to edit the comment, edit, and actually write in here comment, which comment will put everything in parentheses, which the machine won't try to do, but I'll put up here G54X0Y0Z0, how I'm going to set it up. So I actually have a tool list in the top of my program and a little line of setup for help. All right, we're going to do face mill first, and the only flat area on this is right here. So I pick my trusty 3-inch face mill, and we're going to work out of our own library. So if I go to, let me go to edit the tool. Oops. If I'm in my library, this is my tool list for this operation. Well, I'm going to work out of, we have our Titan building block library, and we made one called the high-speed machining library, which is based on the Titan tools, and we build upon that. So this is our whole list right here. And we keep on building onto it. But actually this selection window is a pretty good reducer of all this stuff. So if I picked face end mill all by itself, there really is only one we use all the time, this 5-flute end mill. And I picked that. I'm going to use my preset data for my feeds and speeds. I'll get into that later on a separate video of how to utilize that. So we're selecting the tool, and in here, these are our presets. I'm going to do face mill finish, which puts in my feed and speeds for that. And on this one, we're going to do stock selections, pretty basic stuff. And your first part, you can use stock top on all of these, and model top should be your last selection. You're trying to cut the top of the model. And both ways, 2 directions. We don't need multiple depths. We're not going to leave any material. And I like turning on extend before retract to make sure that the face mill goes all the way off the part. Hit OK. And now this is our quick simulation. This is our entry move. It loops around and comes to the back. All right. Now, because I updated something, it starts to update other toolpaths. So we'll get up to that. So this would be toolpath 1 right here. Pretty simple. Now we're going to go on to 3D adaptive, and the real purpose of 3D adaptive is to rough something that's got 3-dimensional shape to it. Okay, let's get into editing that. Now in this one, we had to kind of look at, let's inspect the part, by the way. So I'm going to shut off some of this stuff here, and I'm going to use inspect. And I have to look at, I know basic size of this part, but I need to know some radiuses because that'll kind of determine my tool selection. So this is a pretty big radius right here, and that says 0.625, so that's really big. Let's pick this radius here. Now if if you keep on going inspect, it's going to try to relate to everything else. I'm just trying to do independent. Let me pick this radius here, and that says 0.375, so I can use up to a 750 diameter tool. Let's hit this one, and this one is selection 2, and that's not really getting me what I want. We hit inspect by itself again, and that it's only telling me length. That's not really helping me a lot. And what else can I look at here? It's got a flat area here. It's flat here, flat here. It has got curves here. So this could be a regular flat end mill area. This could be a regular flat end mill area. These are basic chamfers. I'm looking at the design here. It's an angle cut. angle cut, so it's 45 degrees. These have no chamfers on them, so, but I do want to do deburring on that, so I probably want to add that to my list. I also want to have a little, I want to spot drill and drill those holes, so I want to inspect what size they are. That hole is 0.250 diameter, so that's going to be my finished drill size. So I can kind of build my tool list out of that. And so I got a face mill to do the top, chamfer mill to do the edges, spot drill to prep for the holes, drill for the holes, and this is aluminum, so I'm going to use probably rough and finishing strategy with same tools. Let's use the trusty 1/2" end mill. So I'm going to go edit tool 1, which I would be calling up 3D adaptive. This is what we're doing right now, 3D adaptive. And right now I have a 3/8 flat end mill, but I'm going to go select the 1/2" and just see how far I can get. So I'm going to go to my high-speed library, and I'm going to narrow down my selection to flat end mills. All right, I got my trusty 3-flute 1/2 end mill. I'm going to pick my adaptive 30% setting, hit select, and go to tab 2. I'm using stock contours and rest machining. So because we pre-machined something, we can use the rest machining option. Step 3, we're going to use model top from here on out, and model bottom will identify the bottom of the part. And I'm actually going to overextend that by 10 thousandths. So I need to go negative 0.01. Okay. Passes. Here we get into some settings here. Let's go right down here. Tolerance. I'm going to leave this at 4 thousandths. This is a roughing strategy, so I'm going to be less than 5 thousandths. I want to engage machine shallow areas, and if I hover over it, I can see what that means. Minimum shallow depth step down, and maximum shallow step over. So they got step down and step over. Optimal load. So I have it based on 30% of the tool diameter, but if I didn't have that set in there, I can go 0.5 times 0.3, tab, hit enter. That should self-calculate. I think I did it a little bit too quick, but all these tool paths take a little regeneration time. I'm just going to wait a second. And I want to go back and see if they're locked in. Okay, I'll let it regenerate, and I'm just going to really look at just toolpath by itself. And maybe a little bit of step up and step down. We'll just take a look at that. So let's look at first two tools. Simulate. All right, I can use either, I like using operation or comparison. I'm going to do comparison. And hit play. I'm going to do it. This is going to be the first tool, so that's creating the top, the flat area. All right, next one is going to start the roughing process. And we're holding on by the bottom, so we're not cutting all the way. It's whittling. It's some of it, I think it's multiple cutting, but I think this is all working out good. I'm going to shut off the tail tool path here so I can see this better. And actually this gives me a little helper here. Positive, green, and red. So blue is positive or uncut area. Green matches the model, and red would be undercut. And that could be based on tool description, like your shank size isn't spelled out correctly, so it shows an interference area or collision. But this is pretty good roughing. I don't know how far down it can get. So I can kind of do a little pre-inspection and maybe determine sizes, or maybe just take out certain tools that I use all the time and see how far it can get. notice if you zoom up on this, it's setting to do stair steps. This is kind of the purpose of the dynamic roughing strategies.